Welcome to Simple Unit Conversions. This video is part of a series in Foundations of Engineering by Conceptual Calculus. To prepare for converting units, let's first review a more familiar topic, equivalent fractions. We start with a fraction, such as 2/3. We multiply this fraction by 1. Remember that any number divided by itself equals 1. So 5 over 5 equals 1. To simplify this, we multiply together the 2 and the 5 in the numerator and the 3 and the 5 in the denominator. This gives us 10 over 15. 10/15 is equivalent to 2/3. They both represent the same value, although they are written differently. Unit conversions work on the same principle. All conversion factors are equal to 1. So we are always multiplying by 1, written in different forms. Remember that any quantity divided by itself equals 1. For example, 60 minutes equals 1 hour. That means 60 minutes divided by 1 hour equals 1. And 1 hour divided by 60 minutes also equals 1. In both cases, the numerator and denominator are equal to each other. We can use these as conversion factors. Suppose we want to write 15 minutes as a number of hours. We can think of the 15 minutes as being divided by 1 because division by 1 does not change the value. That lets us write the 15 minutes as a fraction. Next, we want to multiply by 1. We have two ways of writing 1: 60 minutes over 1 hour, or 1 hour over 60 minutes. To select the correct one, we think about what we are trying to do. We want to cancel out the minutes and end up with hours. In our original number, 15 minutes, the unit minutes is in the numerator. To cancel that out, we need a conversion factor that has minutes in the denominator. So we use 1 hour over 60 minutes as our conversion factor. We can cancel the minutes, leaving hours as the only unit. Then we divide the numbers to get 0.25 hours. 15 minutes is a quarter of an hour. Let's see another example. We want to convert 15 inches into a number of feet. We need an equation with some number of feet equal to some number of inches. This gives us two conversion factors, one with inches in the numerator and one with feet in the numerator. To choose the appropriate conversion factor, we write the 15 inches over 1 and note that inches are in the numerator. To cancel them out, we need a conversion factor that has inches in the denominator. When we multiply by that conversion factor, the inches cancel and we are left with feet in the numerator. Dividing the numbers, we find that 15 inches equals 1.25 feet. Next, we consider an example that involves two different units. We have a speed of 50 miles per hour, and we want to convert it to some number of feet per second. We need to convert the miles to feet and also convert the hours to seconds. For each conversion, we need an equation. 1 mile equals 5,280 feet, and 1 hour equals 3,600 seconds. Each equation gives us two conversion factors. 50 miles per hour has miles in the numerator, so we select the conversion factor that has miles in the denominator. The miles cancel out, leaving feet in the numerator. Next, we convert the time units. We have hours in the denominator. To cancel that, we need a conversion factor with hours in the numerator. The hours cancel out, leaving seconds in the denominator. We use a calculator for the numbers and get a speed of 73.3 feet per second. Finally, we consider an example with three different units. We have a power of 10 Newton meters per second that we want to write as some number of pound-feet per minute. To convert the force units, we need an equation that relates pounds to newtons. This equation gives us two conversion factors. Similarly, to convert the length, we need an equation that relates meters to feet, which gives two conversion factors. And to convert the time, we need an equation that relates minutes to seconds, which gives 2 more conversion factors. My students should note that you are not expected to memorize that there are 2.448 newtons to a pound or any of the other numbers. This information will be given on all tests. Other students should check with their own instructors about this. Looking at our original 10 newton meters per second, we note that the newtons are in the numerator. To cancel the newtons, we need a conversion factor with newtons in the denominator. Canceling the newtons leaves pounds in the numerator. To cancel the meters out of the numerator, we need a conversion factor with meters in the denominator. This cancels out the meters, leaving feet in the numerator. The original quantity has seconds in the denominator, so to cancel the seconds, we need a conversion factor with seconds in the numerator. Canceling the seconds leaves minutes in the denominator. Using a calculator on the numbers, we end up with 804.2 pound-feet per minute. Quantities with more than 3 units use this same procedure. I hope this has been helpful. Conceptual Calculus thanks VIVA, Virginia's Academic Library Consortium, and New River Community College for their generous support.